All right, we are going to continue optics. And there's going to be two ways for us to figure out what the image is going to look like and where the image is going to be located. We can do what are called ray diagrams, or we can do math. Today we're going to be talking about the ray diagrams. And for a ray diagram, you draw 2 of 3 rays. Okay? Based on what we set up here is that light, which is parallel to the axis, goes through the focus. Okay? Light that goes through the center goes straight. And the third one is just this first one in reverse. Okay, it's light through the focus comes out parallel. Now you really only need 2 of the 3, and I usually almost always do the first 2. Now we're going to skip the math for now and come back to it. We're just going to do some examples. So here's our first example. So for this, you're going to need a straight edge. Okay? And we got the object over here. This is whatever we're looking at. You always draw it as an arrow pointing upward. It could be a tree or a candle or whatever you happen to be looking at through the lens. And remember, the 2 rays that we're going to draw are light that's parallel. When it gets to the lens, it's going to go down through the focus, and light that goes straight through the center. Okay, so the first one, you imagine that this lens extends up to infinity on this line. So even though this parallel light isn't going to hit the lens, you pretend it does, and it hits the lens right on this center line. So take a straight edge and draw across there. All right, so that it is meeting the center line. And then light like that that's parallel has to go down through the focus. So draw it as carefully as you can, going from where it hit that center line straight down through the focus. So my first one started out parallel and then down through the focus. Okay, like that, parallel down through the focus. The second one I draw always goes straight through the center. So like this. Okay, the center of the lens is right in the middle of the lens. Light that goes through the center goes straight. Here's where they meet. So I draw the image right here. Okay, and the tip of the arrow is going to end up down here where they meet. You always draw away from the center line. So there is my image. And based on that diagram, we can describe the image. It is inverted because it's upside down. So the image is inverted. It is shrunk. Okay, over here this is 3 high, and this looks like it's about 1.5 high. And we're going to say it's real because the light gets there. So I could form this on a screen like we saw in the previous video. There was an example of it. So that now I'm going to show you. All right, I'm going to show you another way you can do this. If you can't print things out, you can't draw them this way. We have this extension called Kami, and you should have it. You should see this little symbol on your browser when you're in Chrome. And we can use that to open the file and then draw right in the file with that. So if I want to open this file, I right-click on it, and I go down to Open With, and then I click on Annotate with Kami. And it takes a minute. But there is our notes. And it looks like this. Sorry about that, it opened one that was already done. So now we're going back. So now I've opened it up, And we're going to move on to example 2. And again, you can do a pencil and paper if you want and a straight edge, but I'm going to show you how to use it, use this program to do it. So I'm going to do a shape. I'm going to pick a straight line, and I'm going to make it maybe 2, and I want to make sure I make it black. Okay, so my first line I would draw starts from the top of the object, goes in parallel to the axis here until it hits the middle line, and we have to memorize whatever goes in parallel goes down through a focus. So something like this. All right, extend that way down, way down here. All right, and then the second line goes straight through the center. So top of this, straight down through the center. All right, and try to line it up as best you can. So it's going straight through the center. And there we are. So they're meeting down here. So now I'm going to draw in the image, and I'm going to make it red to make it stand out. And my image goes from actually the center line down to where they meet. All right, and I'm going to change that into an arrow by clicking on here and like that. So there's my image. So now we'll put a little text box in here and we'll say this is our image here. And then over here we're going to say that the image is and in this case it's still inverted. But this time it is magnified. And it is, again, real because the light gets to that point. So an example of this is like a movie projector, a slide projector. I want to make a big image that I can form on a screen. This would be the lens in the projector. And you'll notice it's inverted. And when you put the slides in the projector, you actually have to put them in upside down because this lens is going to flip the image over. Now for our third example, I'm going to go back to doing it by hand. That's here. All right. And here is my object. Now I've moved it even closer. My first ray, I'm going to draw a parallel and then down through the focus. So like so. And down through the focus. So like that. And then the second one just goes straight through the center. And if you've done this well and carefully enough, you'll notice these lines are getting farther and farther apart. They're not ever going to meet. So in that case, you extend the rays backwards, but you do it as a dotted line because the light never really was there. So I'm going to extend this guy back as a dotted line. And I'm going to extend this guy back as a dotted line. And where those meet is where my image is going to be. Okay, so somebody who's looking down here, he sees the light coming like this. His brain thinks it went in a straight line, so he thinks it came from back here. So my image is going to be here. Okay, and remember it always points away from the center line, so it's going to be this way. And we're going to label that guy image. You're going to say the image is, this time it's upright, right, because it's standing straight up. It is magnified. And it is virtual this time because the light was never at that point. So in the other two, I could have formed the image on a piece of paper. Okay, this one you'll never form on a piece of paper, but you can see it, and this is when you use a lens as a magnifying glass. If you're looking at writing with a magnifying glass, it's still right side up, it's just a little bit bigger. And then I'll do our last one, and this is where we have a diverging lens, or a concave lens. Now this time, I'm going to start out with my rays that start out parallel. They get to the middle line, to here. But now it's diverging. So instead of going down through this focus, it's going to go away from this focus. So the light's going to hit here and go off that way. So I take my straight edge and put it on there. All right, and I draw my line like this. And then I'd make it dotted back here, okay, because the light went here, went that way, but somebody looking from back here would think it came from back this way, so I dot it back that way. And then I draw my ray that goes straight through the center, like so. All right, and then my image ends up here. It's just this little bitty guy pointing upwards, so right there. That image right there. And the image is, okay, it's upright. It is shrunk. And it's virtual. Because even though this one does go there, this one doesn't, and any ray that originates from here and hits this is going to appear to come from that point, but the light doesn't get to that point. So it's still virtual. So that is convex and concave mirrors.